We're going to be talking about section 2.5 with using the distributive property to simplify expressions. Before we get started with that, please make sure that you have a printed copy of the notes that you can fill in as we go along. We're going to start by talking about some important vocabulary terms, and you can see that I've given you a couple definitions here. We're going to use this as an example and talk about what is a term, a coefficient, constant term, and like terms. So let's start with a term itself. The term is the part of an expression that can be added together. So you see that we have an example here. I would say that we have three terms. This is a term, this is a term, and this is a term. So this expression has three terms. I'm going to come down here, and if I asked you to list those terms in the example, I would ask you to give me the opposite of x squared as my first term, 2x as my second term, and a positive 8 as my third term. Notice that I have highlighted in the definition the word added. It's important that we are going to be adding them because as we talk about distributing negatives and looking at negative numbers, it may be helpful for those of you that use same, change to rewrite these expressions as addition. Okay, next term is coefficient. The coefficient is the number part of a term that has a variable part. So if we look at the example above, we only have two terms that have a variable part. So we have the opposite of x squared is how I said that earlier, and we also have 2x. When we talk about the opposite of x squared, there is an unwritten coefficient that could be there. Hopefully you all know that that would be a negative 1. And so negative 1 would naturally be our coefficient for that term. Sorry about my handwriting. The coefficient for our second term is going to be the number 2. So for example, if I asked you to list your coefficients, you would tell me that your coefficient is negative 1 for the first term and your coefficient is 2 for the second term. I'm not asking for the entire term when I ask you for the coefficient, so please don't give me the entire term, just the coefficient. Next term we're going to be talking about is a constant. A constant term is a term that has a number part, but no variable part. In this example, 8 is the only term where there is no variable. So 8 is the only constant term here. So I would say, example, just give me 8. And our last vocabulary term to talk about is like terms. Like terms are terms that have identical, that means exactly the same, identical variable parts. If you look at our example, the variable part of my first term is x squared. The variable part of my second term is x. Those two things are not identical. They're very close, but they are not identical. So like terms in this example, I would say that we have none. Hopefully it's obvious that 8 would not be a like term with either of those because 8 does not have a variable part. What we're going to do is I'm going to ask you to switch to the second term, or second page, and, sorry about that, Belle, look for some examples, or look at some examples. What I would like you to do is actually hit pause on this recording, and I would like you to write down what do you think the terms are for the first example, coefficients, the constant terms, and the like terms. I'm going to keep talking so that when you hit unpause, you will have an example ready to go. Okay, so looking at this example, our terms, we have 4 of them. They would be 3x, negative 4, negative 6x, and 2. The reason I'm saying that this is negative is because remember, terms are things that are added together. So if you're going to rewrite your subtraction as addition, hopefully you would see that the sign of the 4 and the 6x is negative. Coefficients. My coefficients here are 3 and negative 6. My constant terms, I have 2 of them, negative 4 and 2. And like terms are terms that have identical variable parts. I would say I have two pair of like terms. The first pair would be 3x and negative 6x. The second pair of like terms would be negative 4 and 2. Okay, hit pause again. Take a second and try the last example. Okay, our terms, again, we have 4 of them. Negative 2x, negative 8, 6x, and 5. Coefficients here would be negative 2 and a positive 6. Our constant terms would be negative 8 and 5. Our like terms, again, we have two pair of like terms. Negative 2x and a positive 6x are like terms. Negative 8 and 5 are also like terms. Once you understand the idea of what like terms are, you should be comfortable with the idea that you need to, that when we have like terms that can be combined, that we need to do so to simplify the expression. So we have 5x plus 6x. Because these are like terms, we have identical variable parts. We are going to add their coefficients, 5 plus 6 together, and the common variable part will remain the same. My like terms in the second example are the 3y, struggling there, and the negative 4y. Those guys are like terms. Sorry, this is me just being a little bit picky about how that looks. So, because they have identical variable parts, we are going to add their coefficients together. 3 plus a negative 4 is negative 1y plus 8. I want you to pause the video and try the last two examples.